Hi all, welcome to another interesting code snippet challenge. Right now we are viewing a code snippet which we are going to crack today, and this code snippet is little complex. We need to gain a lot of conceptual knowledge in order to crack this code snippet. This video is going to be a bit lengthier video, so please be patient enough to view the video completely in order to understand every concept that's been integrated in this code snippet. So let's get into the action. I'm going to launch my IDE, and I'm going to create a specific class with a name called cruise. The class name is going to be cruise, and let's carry the main method. And here let's zoom in to have a better view. So firstly, I'm going to declare a variable inside this cruise class called private int number of passengers, which is going to carry a value called 1. So we are initializing the variable as well here, and as usual this is going to be called as an instance variable, right? It's an instance variable. It's a private variable. The access modifier or the access specifier here, it is private. It's an int type of variable, and we have a explicit initialization which is carrying a value for this variable is 1. The next variable that I'm going to declare here is a transient variable. So we need to learn what is transient, right? So transient is a keyword in Java, and that can be assigned to a variable, a particular variable. So I'm going to use a string type for this variable, and the name of the variable is going to be schedule, and initial schedule is going to be none. So number of passengers in the cruise is 1, and the schedule is initially none. But please be aware that I'm using a transient keyword here, right? There's a transient keyword. So what is this transient keyword is? Why we need to use this transient keyword here in this particular program? The main theme of this program is all about object serialization, okay, and deserialization. Please make a note of it. This is going to be an object serialization and deserialization. Okay, so now what we have here in this program is a transient variable. So this transient variable is more relevant to this object serialization and deserialization. So meaning is, the transient is a keyword which we use for the persistence. That is, usually while we are trying to think of doing some persistence, at that time we might be think of using a transient, because whenever a variable is marked as a transient variable, that variable is not applicable for persistence. So what do we mean by persistence? That we need to understand, right? So this entire code snippet is actually dealt with the persistence mechanism. So what we are trying to persist, that's a question. We are trying to persist an object into an external file. So I'm going to have a file, and in that file I'm going to store an object inside a file, right? So that's why we call it as persistence. Usually while we are working with objects in a program or in an application, as long as the application or the program is running, the object is going to be alive. So the life cycle of an object is only within the period of the application running or the program which is going to run. So if it's going to run for a period of 2 minutes, then this object is going to be alive for that particular 2 minutes. But after that, the object is going to lose its lifespan, means it's going to be garbaged. But when we talk about the persistence, the object is going to be stored in some external file. We are going to store it in an external file so that whenever needed, we can get the object back. So it's even if your application is going to be terminated, beyond the availability of your application, still you can able to access the same state of an object back in whatever state that you have stored the particular object into the external file. with the same state, you will be able to access the object back and you can make use of it. So this concept is called as persistence, and what we are technically persisting here is an object. So you can technically call it as a object persistence, right? You can call it as an object persistence, and or we can also call it as object serialization and deserialization. Okay, object serialization and deserialization. So with this technical term, we'll be able to understand how to crack this particular code snippet. So as I said, transient is a keyword which is used for a variable, and if the variable is marked with transient keyword, then that particular variable is not eligible for persistence, meaning is you can't use that variable to get stored in some external file along with your object. So this is again an instance variable, right? So while you are creating an instance for this class, right, and you want to store that particular instance in some particular file, then technically what's going to happen is it's going to carry only with num passenger but not with the schedule. That's the understanding. So the need for transient keyword is nothing but to stop the variable from persisting, right? You are not going to persist this variable into an external file. So transient keywords are meant for that. Usually while we use transient keyword, you have to keep in mind that the variables are not eligible for persistence. This we technically learn more in depth while we are working on ORM frameworks, like object relational mapping frameworks like Hibernate, right? So there we will be frequently using the entity objects which need to be persisted in a database. So at that time we'll be using transient keywords frequently, where when we decide that this particular variable need not be persisted in an object in an using an external file or some external database. So so this is something very much important to make a note of it, because the code snippet outcome is going to be relied on this. So transient keywords are meant for making or marking a particular variable not eligible for persisting. But num passenger variable is going to be persisted because it is non-transient variable. This variable is going to be called as non-transient variable. Non-transient variables are the variables which are eligible for persistence, but the transient variables are not eligible for persistence. So right now we'll have this piece of information. So with that, we'll go ahead and see the next set of code in the code snippet. We declare a scope. Okay, so there is a block, or we call it as a block. Okay, so this is called as instance block. This is an instance block. So people who are new might aware that might be in a confusion that what this particular block is meant for. This block is meant for initializing your instance variable technically. Okay, so this looks like a distractor in the code snippet. Whenever you look at the code snippet, there will be too many number of distractors in order to distract our analysis, right, of the code snippet. So be careful. Anyways, to understand, we have constructor block, we have method block, we have static block. The same way here we have instance block. The instance block is meant for initializing your instance variable. Static blocks are meant for initializing the static variable, right? Technically this block doesn't have a name in it. This block is embedded within the class. So we are going to call this block as an instance block because it is bounded to an instance. Okay, so this block will get called, and we are going to reinitialize the variable called num passenger equals num passengers equals 2. So this is as per the code snippet I'm saying. So we have an instance variable num passenger declared, and initially it is initialized with 1, and then we have a transient variable called string called schedule, which is of type string, and it has a default explicit initialization of none initially, and we have an instance block here which is helpful for initializing your instance variable. So num passenger is getting reinitialized, right? So that is what is happening here right now. So next we have a constructor, right? So now you can see a constructor block comes in public cruise, the same name as the class name. This is a constructor. Okay, so we can call it as what? Constructor block. So why I'm stressing out here is you need to understand the difference, right? This is not a constructor block. This is an instance block. This is your constructor block. This is your constructor block. We have a name for that constructor, and that is none other than the same name as a class name. But if you notice here, there is no name. If you look at a static block in Java, you will at least have a keyword called static here. Okay, even that we don't have. The reason is it is only an instance block, so you will not have any name in it. Okay, so what's happening inside the constructor? That we need to understand. So inside the constructor, I'm going to do some set of a reinitialization for the variables that we have created. So the first one is this. We are using the this keyword in order to point out to the current instance num passengers equals 3. So again we are reinitializing. So initial value of the num passenger was 1. Later on the instance block call we have num passengers equals 2, and later in the constructor block we are reinitializing again to the same num passengers variable with a value of 3. So now we need to figure out what's going to be the output of the num passenger, whether it's going to be 1 or 2 or 3, or the whole program is going to end up with a compile time error, or the whole program is going to end up with some exception that's going to be blown up. Let's wait and see. So inside this we are going to have another reinitialization for the variable called schedule. Okay, this dot schedule equals schedule is the cruise is going to head towards an schedule called tropical island. That's what is given as per the code snippet, right? So we have a tropical island. Great. So what we have here is we have the instance block, the member instance member variables, transient variables, transient instance. It's an transient instance variable. Okay, transient instance variable, right? Then we have an instance block, we have a constructor block. Good. Now inside the main method we have the actual logic to be written in order to perform the persistence mechanism. Now before that, as per the code snippet, we are using an varargs, so string 3-dotted symbol, and the name is going to be passengers. So this is again a kind of what to say, a distractor, nothing to worry upon. But let's stay more focused on the way the code snippet was drafted. So I'm writing the same exact syntax of what we have on the code snippet. So string varargs and the variable name is passengers. That's it. So getting into the main method. Now what we are going to do is the first thing that we are going to do is we are going to bring up a try block. So this is more of persistence. So we need to deal with an external file, right? So we need to have the file handling piece of code. So technically we are going to start with a try block, but this is going to be something unique. Probably few people might be aware of this code snippet. I'm sorry, the try snippet, or people might be new. So you need to have some knowledge on this. This is going to be quite unique. Generally what we have in the try block syntax is it will be like this: try, and you have a catch, and you will catch the exceptions. Technically the exception is going to be let's say IO exception. This is dealing with input output, right? So I'm going to catch with an IO exception. So if it's going to be an IO exception, you catch it this way, that is try and catch, right? But that's not the way how we have done right now in the code snippet. So this is not the style of code that we are seeing on the code snippet right away. Why? Because the style of code that we are viewing on the code snippet is called as try with resources. Okay, so technically you will have a try block, catch block, and finally block. So why we need to have a finally block? The finally block is used to get executed irrespective of whether the exception occurs or not. That's a general definition, everyone knows about it. But what we technically do inside the finally block is we need to release the resources. So we need to release the resources that's been created from the try, and due to an exception, or if there is no exception, still the resources need to be released. Meaning is, we need to close all the resources, close the connections, for example. That's what we technically do in the finally block. So try, catch, and finally. This is how we have been practiced to use exception handlings in a Java-like program. But the code that we are viewing on the code snippet is slightly different. We are not having catch, we are not having finally block. Neither the catch nor the finally is there. We only have try, and that too try is having a special syntax with an argument. This is called as a try argument. So this concept is technically called as a try with resources. Okay, try with resources. Great. So try with resources is a concept introduced. It's a style of template. It's a style of code template introduced from the version of Java 7, or we can call it as Java 1.7 or Java 7. Introduced from the version of Java 7. Try with resources. So what does it mean is, when you are using a try, and if you want to surround your checked exceptions, right? The file handling related codes will all fall under the checked exceptions. So which need to be surrounded with proper try and catch. That's what the compiler will let you know as. So such lines of code which need to be used inside the try block can be passed into the parameter of the try. Okay, this particular code what you're viewing here is like a parameter for the try block. So in the parameter, I'm going to create the objects. What objects am I going to create? The file input output related objects. So the very first thing that I'm going to use here is object output stream. I'm not going more depth into the object output stream, the file handling classes, but let's have some base understanding of this. So object output stream. So what is the theme of this code snippet is to make the object persisted in an external file. So I am creating an object output stream object. A reference variable is created, which is called as let's say O, and create a new object output stream, right? So we are invoking a constructor, and the argument for the constructor is going to be a file output stream. So we are going to create a new file output stream like this, and the value for the file output stream constructor is going to be the location where the file is going to be. That is the name of the file, or technically the location of the file. So the file name that I'm going to give here is ship.txt. It's a text file. Okay, ship.txt, right? So this is what we have here in this piece of try parameters. So what we have here is the object output stream, and we have the instance for this particular the instance of the file output stream, which is an argument for the object output stream. Okay, now it says it is unhandled exception. This object output stream might end up with an exception where whenever you use a file output streams and object output stream, this is a checked exception. The type of exception that you might face is IO exception, because the file might not exist, or the file might be corrupted. Something might happen at the runtime relevant to the file. So compiler is cleverly identifying that this might end up with some problem. Okay, so what we have to do for this, what is that solution is, either we need to have a catch here, or you can even survive without a catch. This is something new again, right? Technically, when you have a try, you need to have a catch for it, at least a catch, or you need to have a try and finally block, right? Combination should be try finally or try catch, or try catch finally also. But this code is going to be slightly different, because you don't need to have a catch also, because this is a try with resources feature, the new feature that got introduced from Java 7. So what I'm going to do right now here is I'm going to use the clause called throws in order to throw the exception that might raise here. So I'm not ready to handle it, so I don't want to use catch block. That's what the code snippet says, but it's good to have a catch in order to handle the exception deliberately. But I'm not handling it. In order to handle the exception, I'm just throwing that exception to the caller. technically who's going to be the caller of the main method? The JVM is going to be the caller of the main method. So let the caller handle it, and obviously JVM won't handle. So if that is an exception, then your application is going to get terminated abruptly, right? So this is what we have right now. So you can closely monitor what is that technically happening. Okay, so we have a try with resources with a parameter wherein we are able to create an object of object output stream, and the parameter, the constructor parameter for the object output stream is none other than your file input stream, file output stream. So what is the advantage of try with resources? What is going to be the advantage of try with resource? That we need to have a bit of learning. So what is the advantage here is, this is a resource. O is a resource. File output stream is a resource, right? These resources are technically called as a connection. Okay, a connection which is opened automatically. The connections are going to be opened, and if anything goes wrong in the application, or if the application gets executed successfully, irrespective of whatever happens, the resources, the connections which got opened, need to be appropriately closed, right? So what we need to do is, explicitly we need to use the finally block. Okay, and inside the finally block we need to write the code saying o.close. For example, I'm saying it's an object output stream, so we need to explicitly call the close method to close the object, so that your resources are going to be appropriately closed, right? It is going to have a proper mechanism of closing the resources. But since we use a try with resources advantages, automatically these resources will get closed. So it doesn't require finally, and it doesn't require the programmer to manage and close the resources. Whatever resources that are created within the try parameter, all these resources will be closed. What happens if an exception occurs? Still the resource will be closed. What happens if the application gets executed without any exception? Still the resources will be closed appropriately. Because try with resource advantage is to handle the resource automatically. Handle the resource means closing the resources, whichever resources that got created within the try parameter have to be closed automatically, right? That is the theme behind the try with resources. This is a new style of syntax that we are viewing starting from Java 7. Okay, so this is a bit of information on the try with resources. Now let's get into the try block. Okay, the resources are all created. Now what we are going to do with the resource? It's an object output stream. Object output stream. Output stream means we are trying to provide an output to a specific destination. Who's our destination? ship.txt. So what we are going to store inside the ship.txt is none other than an object. That's why we call it as a persistence, right? We're going to persist the object. Which object are we going to persist? We are going to persist the cruise object. Okay, so what we are going to do here is cruise. We are technically creating an object for the cruise class. Cruise C equals new cruise off, right? So it's going to create an object. So once the object is created, you can say C dot. Now again, calling the instance variables num passenger equals 4. Then C dot schedule equals casino. But if you recall, initially it was none. Later, through the constructor, it got changed to tropical island. Now coming to the instance, after creating an instance, we are again changing the value for the schedule instance variable to casino. So schedule is casino. So right now we have cooked up the object, and we have set the respective value. We have set the value for the respective instance variables like 4 and casino, and finally we are ready with the object. Now if you notice, we have created an object, and the object is ready for persistence into this ship.txt, right? And how it is going to be stored inside the ship.txt with the help of object output stream. Object output stream requires the file output stream in order to map to your external file called ship.txt. So the final line of code that we have to write here is we need to persist the object. Persisting the cruise object. Okay, so that's what technically which is going to happen. Persist or persisting the cruise object. So the cruise object is referred by the reference variable called C, right? So what we can do right now is we can access this object output stream dot. There's a special method called write object. Okay, write the object. Where it will write this object? This object need to be written into the ship.txt. So let's put C out there. That's it. We are done. So later, if in case you want to access this object, you can still access. Beyond the scope of the application, you will still be able to access the object state because the object is getting stored in some external file, and that process is what we call it as persisting process. So object is getting persisted, or more technically they will call it as serializing the object and deserializing the object. Serializing means the object will get serialized in an kind of more of a binary format where we will be unable to read what's there inside the object. Okay, so even if you open the file, you will be unable to read it. Okay, it's more of a gibberish code. Okay, it's going to be serialized, and that serialized code need to be deserialized back to an original object. Okay, so that's why we call it as deserialization. So serializing means taking the object and storing it in a file in more of a gibberish code, and deserializing means the gibberish code is going to be converted back to an original state of an object. So this process is called as object serializing and deserializing, and moreover we call it as an object persistence, means it's going to be stored for a permanent period, so that whenever needed you can access the object back. Okay, so this is what we have in our try with resources logic. Now the next thing that we have to do is, as per the code snippet, we have one more try with resource. So we are going to create another try with resource logic, and inside this we are going to have a logic for reading the object back. So for that, if you want to read the object back from the file, then it's going to be an input, object input. Okay, object input stream, and I refers to like input, new object input stream. Okay, and what's the argument for this is new file input stream, right? Then and inside this constructor of the file input stream, what we are going to offer is the file name. The file name is none other than the same ship.txt. That's it. So now we are ready with this is for writing the object, as I stated, right? This piece of code is for writing the object into a ship.txt file, writing the object, or technically persisting the object, writing the object into the ship.txt file. And what this code of logic is for, reading the object back from the file, reading the cruise object back from the file. Sorry. Fine. So now we can think of getting the cruise object by using cruise C, but I'm not going to create a new instance. Please be aware that I'm not creating new instance. Instead, the instance is going to be retrieved from this ship.txt file, which is already persisted. So as per the code snippet, we are going to use the I object, which is an object input stream, and now we need to use a special method called read object. If you notice, in order to persist an object into an external file, we use write object, wherein in order to read the object back from the file, we will be using a special method called read object. This will return the relevant object in the form of object class object itself. So the return type of this read object is going to be an object class. You have to be aware of it. So you can see right now it's returning an object class object, right? Object type. So which is a topmost class in Java, right? So we need to downcast them to our specific cruise object. That is what we are trying to do here, right? So once you try to read that object from that ship.txt, you will get that object stored in the reference variable called C, and later, as per the code snippet, we are trying to print the value of C dot num passengers plus comma concatenation. It's typically a string concatenation, and then you can say c dot schedule, right? This is what the code snippet was, and I have seen many people have responded on my Telegram channel for this code snippet. So few people said it's like going to be the output of 4 and Casino, or it's going to be the output of 3 and Tropical Island, or compilation. There are different responses. Let's see what's going to be the output of this program right away. Okay, but you would have seen the answer, right? On my Telegram channel, you would have seen the answer for this code snippet. Ideally, it was ending up with an exception. So right now, everything is very much intact towards our code snippet. Nothing different here. Exactly the same style of code that I've written. So let's go ahead and run this program and see why the exception occurs, because the answer for the code snippet was an exception, and why that exception. We need to investigate that. Great. So now you can see there is an exception that's occurring, as I said. Okay. When you run the program, you can notice that there is an exception. What is the exception that is occurring? Not serializable exception. Not serializable exception. Why this exception is occurring? Technically, as I already stated, that we are trying to serialize an object. Write object means we are trying to first serialize the object into an file. Which file? ship.txt file. But unfortunately, while you're calling this method is where this exception occurs. You are unable to serialize the C object. The cruise object cannot be serialized. Why it cannot be serialized? Why there is a not serializable exception occurs? The reason that it cannot be serialized is because any object that you are going to persist in a file or serialize the object, okay, using a write object method, the class should be a serializable class. So the problem here in this code snippet is pretty simple, that this class should implement the serializable interface. Serializable is a marker interface. Okay, serializable is a marker interface. Marker interface. So what do we mean by marker interface? Marker interface means an interface which doesn't carry any method in it. It's an empty interface. Interface is going to be an empty interface, and such interfaces are called as marker interface. This is just for a marking purpose that this class should be a serializable class, so that the virtual machine can understand this class is eligible for serialization. So you need to implement the serializable interface. So if you dig more into the serializable interface, you will get to know what's technically happening. So let's dwell into it. So right away you can see the source code of this serializable interface. It's an interface, right? But technically it is empty. There's nothing inside this interface. Just going to be called as a marker interface. This is just a marker interface. So they have given some pretty good docs as well. A documentation is there. So if you're more interested, you can just go ahead and read this entire documentation and understand what is the purpose of this serializable interfaces. Okay, and this is a marker interface. Why I'm saying it's a marker interface? An interface which doesn't carry any method in it is called as marker interface, and this interface got introduced from the version of 1.1. Okay, so any class, if object you want to persist in an external file, then sure that class should implement serializable. Very much important. Okay, so now with this implement serializable, let's go ahead and run the program and see if we are going to get the exception, or will there be any specific output. Great. Now we are getting the output of 4 comma null. Okay, now there is an output, means your object, okay, your object is persisted in a file. But where is this file? Can we able to explore that file? We have written the object directly into this ship.txt, but I want to explore that file. So you can go to the package from the source or somewhere from the project level, right click and hit the refresh, and now you can see a ship.txt appears. So what is this file? The file is with an extension of text file. The name of the file is ship. So automatically the file got created. Okay, while it is opening the connection, it will go and check if the file exists or not. If the file doesn't exist, automatically the file gets created. After creating the file, the object is getting persisted into this file. So let's go ahead and explore what's inside this ship.txt. So if you see this, you can notice that there is some chunk data is there. Okay, so this is the class name. The cruise object is persisted right now. You can see num passengers. Okay, and you have some junk values here, right? And one thing that you should notice here is there is only an instance variable called num passenger is there, but we don't have the variable called schedule. There is no variable called schedule. We have created two variables, right? One is the number of passengers variable, another one is schedule, but the schedule is not seen inside this serialized code, and that's the reason the output is also null. That variable is not persisted in the file. Why it is not persisted? Because the variable is marked as transient. It's a transient variable, and so it is not eligible for persistence. So in that situation, whatever initialization you have done, the final initialization for the object of the num passenger is 4. Even though we have mentioned c.schedule equals casino, but technically the schedule is not getting persisted in the ship.txt. Only the num passenger goes into the ship.txt, but not your schedule. So the object is getting persisted into the file, and we are trying to deserialize it. How the deserialization happens? Deserialization happens through the method called read object. Read object reads the exact serialized code and converts them into an object, and the object is further downcasted to the respective object type called cruise, and we are trying to fetch the num passengers. Now you can see the schedule instance variable doesn't exist in that object. So technically it is returning a null. This object is not there. It's a string object. Technically this is a string object, and that doesn't exist. So it is a null object. So why the schedule is not available is because it's a transient variable. Transient variables are non-persistent variable. Okay, it's not for persistent. So for time being, let's remove this transient variable and let's go ahead and run this. Now you see the output is 4 and casino. Why it's 4 and casino? Because that object is associated with the instance variables with the value called 4 and casino, and we are trying to persist the object into the ship.txt. So if you get into the ship.txt file again, now you should get to know that there is going to be the string type of variable schedule is also going to exist, and string class is by default a serialized class so that it is eligible to persist inside the object. So the class which is going to use another object, and if that object also need to be persisted, then that class also should implement serializable interface. So schedule is there, number of passengers is there. Both the variables are persisted because we haven't marked them as transient, right? So this is the concept of object persistence or serialization and deserialization. So if you want to understand more in detail about this string, let's get into the string. And here you can notice that string is further implementing serializable. If the string is not implementing serializable, then again you will get a not serializable exception. Okay, even though we are trying to persist cruise which is already implementing the serializable, the cruise which is using string class and that string class object need to be persisted, then sure the string also should implement serializable marker interface. Otherwise you will get the exception. Okay, so probably in the next set of code snippet challenges, we might be encountering such kind of codes as well, so that we can learn that more in detail. So right now we have used a file called ship.txt, but technically we will be using a ship.ser file. Extension is going to be an ser extension, and right now I'm going to run this program and see what's the output is. So right now it's 4 and casino. So let's go ahead and refresh, and you notice that there is one more file got created with .ser. Okay, so .ser means it's a serializable file. This is more of our understanding that this file is a serializable file, a serialized file. it can store the serialized data. So if you open this serialized, it's going to be the same what we have seen in the .txt file. And one more way we can represent that file extension is .dat file. Okay, but moreover, whenever we are talking about a serialization, it's a good practice to have an extension called .ser. Now, it's more portable, right? Let's say I'm going to copy this file. Okay, I'm going to copy this ser file, and I'm going to shift that file into some other machine, or let's say in some other laptop, and I'm going to use a code there in that laptop to deserialize it. This is a serialized file, right? Will I be able to deserialize there if I have the similar set of code? Yes, of course. So it's more of portability. You can transport your object through the serialized file. You store all your objects in a serialized file, dump them into a serialized file, and you transfer it to a specific location, and there you write a code to deserialize them. You will be able to deserialize the data and get the standard of object back by using the read object method, and that's what you are seeing right down here, right? So both are achieved. Serializing and deserializing is achieved by this special class called object input stream. Okay, input stream is technically for deserializing, and object output stream is technically for serializing. Okay, output stream. So what happens here is taking an object, persisting in an external file so that whenever needed you can retrieve it. Even if you shut down this entire system, you restart it, you launch the application, still you will be getting the state of the same object back. You don't need to have this code. Okay, the object output stream code is not required. You can write a separate code just for reading purpose alone, but the file should be available. Ship.ser file or txt file should be available in order to read the object back from the serialized file. So this is the actual concept behind this code snippet. As I said, it's a lengthier video, yes of course, because we need to discuss more in detail. So what are the concepts that you are learning here is a concept of serialization. So there is an interface called Serializable Interface. There is a keyword called transient in order to mark the variable as a non-persistent variable. So we have a transient keyword, we have instance block in order to reinitialize the instance variables, and then we have a constructor block, and then down, more importantly, we have learned something called try with resources. Technically there is no finally block. We don't need to close the resources like o.close and i.close. For that we don't need a finally block because these are auto closable classes. Object output streams, file output streams is all going to use an auto closable interface. Okay, auto closable interface. So if you want to see that interface, I will be able to show them. If you just get into the object output stream, okay, you can see that it's implementing an object output and object output stream constant. So let's go to the object output stream, and here you can see that there is an auto closable. So what is this auto closable? This auto closable is going to be an interface again, and this is another example for calling it as the interface for closing the resources. So auto closable, which is carrying a single abstract method here, which is a close method. Auto closable is used for the purpose of automatically closing the resources, and that's introduced only from Java 7. Okay, so you just go to the object output stream, go to the auto closable, and there you will see the auto closable interface is introduced from Java 1.7 in order to support the closing of the resources automatically with the help of try with resources. So we don't need to use the finally block to close these resources. The most important thing is inside the try parameter, you will be able to use only the class. You'll be able to declare variables and create instances only for the class which implements auto closable. If it is not implementing an auto closable interface, then you will not be able to use them inside the try parameter. Now file output streams, object output streams are all the classes which implements the auto closable interface, and so it is eligible to close those resources respectively without having a finally block automatically. Whether the exception occurs or not, the resources will be perfectly closed by the try with resources. Now the code, the finally code is not required, and the programmer are freed from writing that additional finally block in order to remember that all the resources have to be closed appropriately. That add-on work is now eliminated with the help of an interesting support called try with resources. This is a very important topic. And finally, what we have learned is how do we persist the object. In order to persist the object, the class should implement serializable interface. That's very important point. Only then you will be able to serialize and deserialize the data, right? So that's it from this code snippet discussion. I hope you would have got a better understanding of what exactly happened behind this code snippet. Indeed, it's quite a lengthier video because I have to take you to the tour of complete understanding on the fundamentals and as well as the advanced area of discussions, because we have a lot of new concepts coming into this code snippet. So we need to spend some quite a good amount of time to have a better understanding. So if in case you have any queries, please post it on the comment section so that I'll try to respond it. So thank you all. We'll connect up with another quite interesting code snippet and more complex, challengeable code snippet in the next video. Thank you all.